Welcome to Ferrum Forge Knife Works. Today we have a very special video for you.
Oh,
Don't
it's gonna be special already.
Mm-hmm. So what do we have today, brother?
What? It's come to our attention that we never actually talk about why we do the things we do in a knife. I mean, we
amongst ourselves.
gloss over stuff about what we do, but we never actually talk about it. So, Christopher decided we should talk about it.
I did. So, what we have here, we are currently working on the Scepter knives. I'm sure you've seen them on Instagram on our website. So while we have all the parts available, I figured we'd show every single component that goes into one of these knives. So, why don't you start us off, brother?
I think you got everything. Okay.
I should hope so.
Let's go from big to small.
Okay,
Big to small.
big to small.
Okay. Phase one, our blades.
Blades.
I've used a lot of different steels over the years. A lot. We sat down and tried to list them, and it got dense. Very, very dense.
Yes.
There really aren't very many steels that I haven't used, or at least experimented with.
Mm-hmm.
And what I've come to over years of trial and error is I'm pretty sure that I like 20 CV the best. 20 CV is the same exact thing as M390 or 204P.
Why do you like it so much?
For a high alloyed stainless steel, high carbide stainless steel, it is actually fairly stainless. That's usually not always the case with stainless steels, especially when they're high carbide. So what it means is that it tends not to just rust from being in a clammy, sweaty pocket.
Mm-hmm.
There's a bunch of other steels that we've tried that turns out they do in fact rust being in a sweaty pocket.
The struggle is real.
Yeah.
Mm-hmm.
And then we don't run 20 CV particularly hard in 200 piece run knives. So we run it at 60, 61. And even at that hardness, it really does hold an edge better than most other steels you will find at that same hardness level. And it's impact resistant enough for a folding knife.
Why does a folding knife need to be impact resistant?
Well, it really doesn't. It's always the thing that's along with my mind.
Okay, so that's the blade and 20 CV, our favorite steel. And there's something that we can't really define,
Je ne sais quoi.
right, about the way that the ceramic rolling detent that we have interacts with that steel. It's smooth.
It just works better.
It's smooth. That's all right. What's next?
Next, let's go with scales.
Scales.
So if you've noticed over the years, we almost exclusively use titanium because we really like titanium. And it's lightweight and has a higher strength weight ratio than steel. All kinds of interesting things.
Corrosion proof.
Pretty
rust
much.
proof, I should say.
You gotta work hard to corrode titanium.
It can be done.
It can't be done, but you gotta work real hard with some chemicals.
We've done that work. And then, so aside from its mechanical properties and the fact that it is lighter and flexible and strong, ding fries are done. You can also do all sorts of things with coloring it by anodizing it and playing with the textures and the colors on it to create a whole new spectrum of finishes on a knife, rather than just changing the material. All right, so you want to talk about log scale first or face scale?
What are we going to talk about with face scale? There's really nothing super important about them. They have holes and bearing pockets.
Well, the bearing pockets are important.
Bearing pockets are the most highly dimensioned part in our knives. I've designed everything else on our knife to not require extreme precision, except for the bearing pocket. And that is the one thing that we actually spend the most time getting fine-tuned when we fit a knife together, is the depth of the bearing pocket.
Because our tolerances are actually tighter than what a machine can do. We set them by hand. We get close enough with a machine, and then the final touch is all done by sight and by feel by me and Elliot.
Indeed.
Mm-hmm.
It is super special.
Lock scale.
Where the real magic happens. So, quite early on in my career, I happened to notice that, as so many have, that titanium, it loses the battle against hardened blade steel over time, and you get lock rot.
Mm-hmm.
Almost always. And I don't care how magical your lock interface is and your angle or the concave that you're using, eventually the titanium will lose. And it doesn't matter how much carbide impregnation you put in it, it eventually deforms and wears off, and it just happens. And I love watching people heat harden their lock interfaces, which cracks me up. Because all they're doing is creating a thing called alpha case, which is actually really brittle. So it tends to crack and deform over time.
Mm-hmm.
So the simplest way to get around that problem is just put a piece of steel in there. Currently all our inserts are D2. It seems to match wear resistances enough with most of the blade steels that we try and use to where it isn't, where they meet up well. They wear in together at a fairly similar rate. And we are realists here at Ferrum Forge, and people assume that just because we bolted it in here that means it's replaceable. That's really not the intention at all. I just had to come up with a way to put steel on titanium. And also, we have this lock insert as a standardized part for us. So the same lock insert we have made in large quantities, and that way they're cheaper. Because boy, were they expensive before.
Mm-hmm.
When we were doing a unique lock insert per model, it was they were astronomical. They were almost the same cost as the face scale.
Well, and that's one of the things on why those little small runs, the model runs from 2014
In 2015.
and 2015 were expensive. Because they were expensive to make.
And so, going along with realism, we'll talk about other components of our knives that are supposed to be replaceable. So, I don't expect every knife I ever make to never have lock rock. That's just unrealistic. Does it take a long time for them to develop lock rock? Years? Maybe. Depends on the amount of use they see.
Thousands and thousands and thousands of flips.
Depends how much opening and closing they see. And so knowing this and knowing knife owner behavior,
We are guilty of this too.
We
Every
do it
time we
all
sit in
the
the
freaking
office and are
time.
talking, click,
opening and closing knives.
click. We get it.
So we have another component that is actually replaceable. It is our stop pin. They screw into the scales, and they are also shouldered so they fit into the titanium itself. So they pop in, and this one is really nice and snug because this is a
very fresh piece.
hole hasn't been re-reamed. And so not only do we have the benefit of having a through member that is actually inside of the titanium, but it's also screwed in there. So it's actually two levels of being stuck in there. So it's basically press fit as well as screwed in.
The shouldering gives us maintains dimension.
I was going to get to that.
Okay.
So these little bad boys, right? This is our standard size one. It's 150 thousandths diameter. We actually have these in three other diameters. So like if you have one of our knives and it develops lock rock and you send it back to us, the normal operation we do is we put in a larger size stop pin.
These are also heat-treated steel.
Yes, they are. This particular batch is they're 17.8 precipitation hardening stainless. I just know that off the top of my head. So the other thing that our stop pins do is they actually set a very specific dimension across the front end of the knife. So the pivot is not responsible for maintaining dimension. Actually, the only thing the pivot does is keep the blade from falling out of the knife. That's its only job. That's the only job I wanted it to have. So our stop pins are a specific dimension, 195 thousandths, and they are always 195 thousandths. So the front ends of our knife are always 195 thousandths.
Always.
Always.
Mm-hmm.
And therefore, that dimension is maintained, regardless of how tight or not tight the pivot screw is. So simple.
It's so simple.
And then we have standoffs that have the same cross dimension as well as being shouldered, so they pop into the scales and then get screwed in.
And these are titanium, so which means they can be colored.
Indeed.
You know how I love to do that.
In smaller knives, we usually only do one, because we actually already have 2 points of dimension setting and contact and stabilization throughout the system.
Stabilization. Yeah, shouldered standoffs and stop in. Nothing's gonna slide or shift on you.
And I know, because I've dropped so many of our knives. So many.
We know it's not gonna be a good knife until it gets dropped.
So let's talk about our freaking pivots.
Let's talk about pivots.
Oh god, pivots are a
So-
nightmare.
We use a very specific part for this. Alright, and you'll notice that's an 1/8 inch pivot.
Oh my gosh. How?
So we have very specific reasons, and we've done some research and math to determine that the 1/8 inch pivot,
Science.
we science this, that the 1/8 inch pivot is the best option for the application in our folding knives. Why is that, brother?
So, if you measure the wall thickness of this 1/8 inch pivot, and then you measure the wall thickness of other commercially available 3/16 inch pivots, what you'll find is that the 3/16 inch pivot is really not that much thicker, the wall thickness. In fact, it's only like 17% thicker. It's only a couple of thousandths thicker. And so, the actual diameter, which translates into surface area that our blade is going to ride on in here, is 36 or 38% more. So if I'm sacrificing 17% of wall thickness, but I'm gaining 38% reduction in surface area, that means that I'm reducing friction. And since all of our knives are flippers, the reduction of friction for a marginal sacrifice in strength seems like the better option. And after, let's see, we've, I don't know, over 3,000 knives with 1/8 inch pivots in them. You know how many have come back with bent or broken pivots?
How many?
Absolutely none. Absolutely none. Because, again, our knives are a system. They're not just each individual component. They all add up into a system.
The whole is greater than the sum of the parts.
In this case, 100% true.
Yeah, no single part or component of the knife is ever taking all of the force,
Whatever that force may be.
whatever that may be.
I mean, because we do some dumb shit with our knives. Some dumb shit.
I don't know what you're talking about, bro.
And so, in designing a system, it's also appropriate to design in fail points in the system, like the crumple zones in a car. So the fail points in one of our knives are always the screws. Why are they the screws? Because those are the easiest part to replace. And coincidentally, the cheapest part as well. So, we've had people like catch their knives on a car door and it pull the scales apart, and all it really did was just pop the screw off. And so we just put a new screw in it and it was fixed.
The customer was very, very surprised by that.
whoa, I thought it really no, it failed in the fail point. That's where it was designed to fail.
And the beauty of titanium, if you can deform that thick of titanium just by catching your knife on something and not, I don't even know how you could do that. You need to tell us about it, because that is amazing. Right, that is a feat of strength that is very impressive.
Okay.
talk about bearings?
They're so annoying.
Well, alright, so let me ask you this then, brother.
Okay.
Why is it that we use caged bearings over like an IKBS system?
Well, because they're way less annoying than IKBS. And they'll fall out all over the place.
And again, we are realists with a knife, right? If it's gonna live in your pocket, that means it's gonna get cluttered with pocket crap, lint, whatever it may be, right? So we get it. You're gonna need to take your knife apart, or you're gonna want to at some point, and clear it all out. Now, when you take it apart, the bearings come out, and that's it. And some of you who have ever taken apart a knife with IKBS, I made that mistake once. I will never do that again.
Yeah, that was it was fun, wasn't it?
That was awful. Because I wasn't expecting it, and they just went.
Did I warn you? I'm pretty sure I warned you. I said, hey, be careful when you take that apart, because, you did it.
Yeah, it was. Yeah. Thanks for the heads
They
up,
went.
bro.
Good thing we have more.
Mm-hmm.
So we actually use a really small bearing with little teeny tiny balls. Most balls are, well, some balls and bearings that are commercially available are 1/16 of an inch in diameter. These are actually metric, and they come out to being 0.0476.
Niner. And again, this is all in reducing surface area.
That's what bearings are supposed to do.
Mhm.
They reduce contact area, which thus
Reduces friction.
That's the whole point of the bearings.
Because we all know friction is a function of surface area.
Yes, we all know that.
We all know this.
Everyone knows that.
Okay.
But is it dynamic or static friction?
Well, that gets a little trickier there, Chief. I'm a knife maker, not a physicist.
Okay. So, rolling
And
detents.
then-
We'll talk about rolling detents.
This.
Isn't that adorable? God, they're a pain in the butt. So we actually make our own rolling detents. Right, we have a Swiss screw machine place that turns the screws for us, and then we pop in the ceramic balls.
You designed this part, right?
Yes.
Mm-hmm.
So we used to use one, the same one that Jake Hoback uses, and I actually found it for Jake years ago. And it had a weird metric thread, and the company that makes them in Japan would not put ceramic balls in them. They never gave any of us a good reason why. And so I said, all right, cool, I'll design one and then have it made. And so we actually make the damn things ourselves. And we've gone through a bunch of different generations of these. I mean, some had straight slots and they were terrible. And we went back to using a hex drive. We had some that were star drive. They were T6. They were a little too expensive.
Yeah, those are pricey.
And so they're all going to be hex, but a hex that fits a T6.
Mm-hmm.
And we had them made ourselves also because I wanted to use a different material. They were using 304 stainless. I didn't like 304 stainless because the screw body itself often ends up coming in contact with blade steel, so I wanted it to be a little more robust than 304. So these are actually 17.8 precipitation hardness stainless.
Mm-hmm.
Let's see. What else are we going to talk about?
Oh, you got pocket clips.
Oh yeah, pocket clips.
Obviously. Alright, the pocket clips.
Pocket clips.
So, titanium bend clips. Right, and we have put so much time into getting the tension on these things right, because we understand a pocket clip needs to hold the knife in the pocket. You don't want to destroy all of your pants though. So we've been working with bend clips now for 2 years.
Mhm.
Personally, I prefer a bend clip to a milled clip. I think they're lower profile. I like them better, but to each their own.
Indeed.
Mm-hmm.
Some people have asked me, how come we don't do mirrored machining on our lock scales like we do on our face scales? And there's two main reasons for that. Number one is cost. Lock scales are already more expensive than face scales. Even face scales with more intricate machining like that armor plate pattern, that lock scale still is more expensive. So it starts driving the cost on our lock scales into the double of what they normally cost price range. And then
That's
that's the part of the knife that touches your pocket the most. And it actually has force applied to it by the pocket clip, so it's just easier to have them nice and plain. That way they slide in our pockets nicely.
Because we've done knives in the past, some special versions that had machining various things on the lock scale, and yeah, it tends to catch on the pocket, and everything's gonna rub off where it contacts over time. So that's it. There's the knives. Oh, we didn't mention that we do try and keep the same head. All of our body screws are T8s. The smaller screws are T6s, and some of our pivot screws are T15s. The standard ones are a T8 as well, so you don't need a bunch of different tools for anything. It's all the same. It helps us out.
Can't think of anything else that's remarkable.
Well, it's not until it's all a knife that it becomes remarkable.
This is very true.
I mean, these are just parts.
Just parts.
You haven't worked your magic on them yet, bro. These are just really expensive
Not
pieces
like
of
all
titanium.
These other parts that I've worked my magic on. Just a couple. It's no big deal.
Do we have any? This game. We have raw, unfinished parts, and then a beautiful blue, blasted and tumbled chunk of titanium.
Don't cut yourself, bro.
All right, Gapco.
You wanna go look at other stuff?
We can look at some little teasers, okay? What do you want to look at? We're at 22 minutes.
I don't know what you would look at. It's a table of pretty. I'm just
I
saying.
mean, we might as well. Lighting is. So we got some of the Maker's Choice scepters.
Freaking purple light.
Oh, hey, look at that.
Hey, whoa.
What do you know? So these ones we didn't have, really didn't have a specific theme in mind. So it was more of kind of doing the things that he's enjoyed over our past Maker's Choice runs, and then turning it over to me, like we do. And I decided to go a little on the brighter colors, some colors on titanium that you don't see very much, and mixing the colors, of course. Here we go. And copper. We rediscovered how much we love copper and coppery colors.
Grief, dude. Especially that one.
This one,
It was actually my least favorite until those colors. Now it's
yeah. Focus. There we go. Yeah, I'm a retard and push the stop button, so here we go again. Anything else you want to show off?
videographer. You might not be, sir.
Listen, sir, I'm a man of many talents. Being a cameraman needs some improvement. Kick you in the nuts.
You will try and fail.
This is smart. Any other thoughts? And we're gonna do a full breakdown video of the Maker's Choice.
Of course.
Of course. With a little better lighting and complete knives that work.
Easy.
Mm-hmm. Last thoughts?
Do we want to talk about what we're planning on doing in like a week or two with stuff on the website?
I have nothing made for that yet, so.
Oh, it's all about you.
Yeah. You're just now getting that? Jeez. I wonder if we can just say there will be announcements. We're gonna have, as I'm doing more experimental finishes, coming up with names for them. Like we have the new Leviathan finish that will be coming out.
Oh, the Leviathan finish.
That's the only one I have a name for
That's all
right
you got
now.
so far?
That's all I got. So we'll debut that.
Leviathan finish.
It's a good one.
Okay.
I don't know what to call the one on my.
Hold on, I gotta check on my heat treat items.
And there's a puppy. Don't eat. Aw, you. Aw. Alright, we're signing off. Bye, YouTube.